Welcome back to my channel. Today we are going to discuss a concept related to de Broglie hypothesis. According to de Broglie, any material particle, it can be neutral or charged, in motion is equivalent to a wave. According to de Broglie, any material particle in motion is equivalent to a wave. The wavelength is given by the corresponding wavelength associated with that wave is given by lambda equal to h by p, where h is the Planck's constant and p is the momentum. For a charged particle, we can write the kinetic energy associated with it is kinetic energy Ke associated with it is equal to charge into potential. If we write the charge as Q or E, we can write it as EV, kinetic energy associated with a charged particle of charge E equal to E into V. Now we are going to find the de Broglie wavelength associated with charged particle in the non-relativistic and relativistic case. First we are going to consider the non-relativistic case. Non-relativistic case. In the non-relativistic case, kinetic energy Ke equal to p square by 2m, where p is the momentum and m is the mass. So lambda, non-relativistic case, equal to h by modulus of p, because here p square, we have taken p square. So from this equation, p square equal to 2m into E, where E is the kinetic energy. So lambda non-relativistic equal to h by modulus of p. Just we can write kinetic energy K, Ek. So it is equal to h by h. Here from this it is equal to p equal to root 2me or Ek, just E. So it is equal to root 2m into E. For a charged particle, it is equal to EV. So it is equal to h by root 2m E into V. This is the wavelength related to de Broglie wavelength associated with a charged particle in the non-relativistic case. If we use charge Q instead of E, we can just put here Q here. 2m into QV. Now we can deal with the relativistic case. In the relativistic case, the kinetic energy E equal to the total energy E equal to kinetic energy plus m0 into c square. That is equal to root of p square c square plus m0 square c raised to 4. So squaring total equal to kinetic energy plus rest energy m0 c square, which is equal to root of p square c square plus m0 square c raised to 4. So for the charged particle, kinetic energy is QV plus m0 c square equal to root of p square c square plus m0 square c raised to 4. Squaring both sides, we get QV plus m0 c square whole square equal to p square c square plus m0 square c raised to 4. So QV whole square plus 2 m0 c square QV plus m0 square c raised to 4 equal to p square c square plus m0 square c raised to 4. On both sides we have m0 square c raised to 4. We can cancel these two terms. So the remaining terms are p square c square equal to qv whole square plus 2m0 c square into qv. Taking 2 ev, m0 c square outside, 2 m0 c square qv into 1 plus qv divided by 2 m0 c square. We can cancel c square from both sides. So p square equal to 2 m0 qv into 1 plus qv divided by 2 m0 c square. So we obtained an expression for p square as p square equal to 2m0 qv into 1 plus qv by 2 m0 c square. So we obtained p square. Now p equal to root of 2 m0 qv into 1 plus qv divided by 2 m0 c square. This is the expression for the relativistic momentum for the charged particle moving under the influence of a potential V. Now from the de Broglie equation, de Broglie equation for wavelength, lambda relativistic equal to h by v modulus of p, that is equal to h divided by root of 2 m0 qv into 1 plus qv divided by 2 m0 c square. This is the expression for the relativistic wavelength, de Broglie wavelength. Thank you for watching the video.